Here in our Human Factors Lab in Cambridge, Massachusetts, our human factors psychologists and engineers study the interactions of humans and the automation systems that move America. The Volpe Center is the National Transportation Systems Center, and it has been present here in Cambridge for more than 40 years. I'm sitting here in front of the Cab Technology Integration Lab, and we refer to it as CTIL. This is a brand new state-of-the-art simulator that was designed and acquired by the Federal Railroad Administration and is housed here at the Volpe Center. We operate it for the Federal Railroad Administration, and we conduct research on their behalf, and we also support researchers who come in from various places to make use of this new facility.
The concept behind CTIL Lab is that it's a tool. It's a tool for research, for not only for the FRA to do research, but for the industry, the railroad industry, and for academia as well to come in and do research about various aspects of technology that has to be moved into the cab and used by locomotive crews.
We have a 25-mile-an-hour temporary speed restriction at 199.5 coming up, over. Starting in 2008, we began to more closely examine the causes of major rule violations. Now, railroad rules are something that every railroad has for their employees to follow to ensure the safe operation of their trains. And unfortunately, because of the nature of human fallibility, there are times when people, for one reason or another, do not comply with the rule. We compiled evidence that indicated that up to 70% of major rule violations were due to elements of distraction of the employee. So at that point, we contacted the Federal Railroad Administration and proposed a study whereby we could reconstruct elements of distraction in a laboratory condition and measure those. Ultimately, our goal is to identify the causes of distraction and create some training that we can share with the entire railroad industry in order to make employees aware of distraction, make them cognizant of how distraction can affect them, and most importantly, to develop some strategies so that they can reduce distraction while they're at work.
How can we prevent or minimize distraction and its effects on crew performance in the cab? These are all things that Veolia is interested in looking at, and we at the FRA are also very interested in knowing about those things from the safety perspective. The thing that makes this simulator different from most of the other training simulators is that this one is designed specifically to be used for research purposes. So what has been incorporated into the design of this particular simulator are researcher tools that will help us measure human performance. The concept of operations, if you will, behind CTIL is that this really is a national resource. We are working together and collaborating with the railroad industry to get at these types of problems. We situated the CTIL here at the Volpe Center up in Cambridge, Massachusetts, and their role in this is to house the simulator and also to assist us with doing research efforts there. There's a marvelous staff of human factors experts at the Volpe Center. We use the Volpe personnel to help us in research in terms of programming the simulator itself and helping with the railroads as they come in to do research, help them set up their scenarios and collect data.
Ultimately, we'll know where your eye is in three-dimensional space. So this is the Nodus Observer. It's our analysis tool. What it really allows us to do is it allows us to take data from different sources being recorded during the simulation and put them together so that we can have something that we can refer across data sources for the purposes of analysis. After the information is collected in our data stream here, as the data has come in through a web browser, we save the information and then we import it over here into our data synchronization tool, so that way we can then do our analysis.
This simulator compares to the real world in that it is a realistic depiction of a commuter rail line. It has the signals are very similar to the real world. You'll see stations, buildings along the right-of-way, passengers on station platforms, vehicles on grade crossings. So it's a very realistic portrayal. You know, we think this study will contribute to avoiding accidents or incidents or rule violations to help locomotive engineers do their job better and operate safely out there.
This study is first attempting to document empirically under as close to realistic conditions as possible whether such distraction-related errors occur. And then the second part of the study is to implement a training program to try and reduce the incidence of such errors. Also, the simulation, from the point of view of psychology and human factors, it affords a very controlled environment where we can precisely control the speed of the train, the conditions of the track, the environmental conditions, the type of operators. These are all things that are difficult to control in real-world field studies. And we can empirically compare different conditions that differ only in the level of task load or workload. It really is a groundbreaking study that's attempting to document the existence of distraction-related errors during simulated rail operations.
Because we have the capability to reconfigure the cab, that opens up the possibility for doing all sorts of studies related to different kinds of cab layouts. What are the best ways to design controls and displays for crew use? And a whole variety of different research studies are capable now.
Central to all of these transportation modes is the human, and we address the issues of the cognitive and perceptual and situational issues as part of this research in the Human Factors Lab.
Again, it's that tool that's at the centerpiece of this that enables better collaboration between the FRA and the industry, as well as academia in human factors research.